Hello and welcome back to Ganesh Institute. So in today's video, what we are taking up is another topic from complex analysis, that is analytic function. Okay, so let's first find out which sort of function is it. Okay, so if I give you an example that there is a function in the form of z when it is equals to 1 by z. It is equal to 1 by z. Can you tell me where it is not defined? You cannot have z as denominator, 0 as denominator, correct? If you have, let's say, 1 upon z minus 1, you cannot put z as 1 here because it will then make it 1 by 0 form, which is not defined. So, if you want a function to be analytic, there are some conditions. Firstly, that function has to be defined on the point where you are checking its analyticity. Okay, so if it is not defined somewhere, that point is called as singular point. What is it called? Singular point for that function. For example, 1 is the singular point for 1 upon z minus 1. Okay, first of all, check out if there is any singularity or not. If the function is defined everywhere where the question is asking for, then check whether it is continuous or differentiable. For example, you know that if you have x square plus 2, this is a polynomial function, so it is defined everywhere, so it is continuous as well as differentiable. Polynomial function is continuous and differentiable. Similarly, you have sin x, cos x, trigonometric periodic functions. These are also continuous and differentiable. You know how to check continuity and differentiability, right? You check left hand limit, right hand limit and the value of the function at a particular point. If these are equal, then function is continuous. Okay, and similarly for differentiability, you have a point where LHD, left hand differentiability, is equal to right hand differentiability. Now once you checked out that okay, the function is continuous as well as differentiable, which are the necessary conditions to be analytic, then you check for Cauchy-Riemann equations. What are these? Cauchy-Riemann. Let me write. This is Cauchy. Riemann equations. What are these equations? Here you have the role of partial differentiation. Okay. Let's say if you have a complex function in the form of u plus iota v, where u is the real part and v is the imaginary part, and you want to check its analyticity in domain D. So what you will check, whether u and v are satisfy Cauchy-Riemann equations. And these equations are ux has to be equal to vy and uy has to be equal to minus vx. Okay, at every point in domain D. Now what is ux? Ux is nothing but partial differentiation of u with respect to x. Vy is partial differentiation of v with respect to y. First equation is this to be satisfied, and second equation is partial differentiation of u with respect to y has to be equal to negative sign of partial differentiation of v with respect to x. Okay, how can you check that? You know, for partial derivatives you have another law as well. How can you find out partial derivatives? Let's say if you have x square plus y. For example, this is the question and you have to find out the partial differentiation with respect to x for this function. With respect to x, you will do, this will become 2x because there is no x component here in y, so its derivative will be 0. Similarly, if you have to find out with respect to y, there is no y in x square, so its derivative will be 0, partial derivative, and for y it is 1. This is how you can find out. Also, you have some formulas for partial derivatives. You can check out those videos where I have already discussed partial derivatives. Here if you have to find out partial differentiation of f, the function, with respect to x at certain point, let's say ab, that will be equal to limit h tends to 0, f, because it is with respect to x, so there will be change in x only. It will be a plus h. The point is a plus h, there is increase in x value, comma b, because you already have ab as a certain point, right? Instead of xy, you are going to put ab in the function. Now for x, you will increase x component by h minus fab upon h. It is something similar to differentiable function, right? This is how we find out differentiability. Similarly, if you have to find out differentiation of a function with respect to y at certain point ab, what you will do? Limit k tends to 0. Let's say now the component which has to be increased is k, or the y component will be increased by k, okay? So a comma b plus k minus same ab divided by k. This is how you can find out the value of partial differentiation. Is it clear? Now if I ask you how can you use these in examination perspective, so let's say there is a question that u in the components of xy is given to you, which is root modulus xy, and vxy is given to you as 0. You have to show whether the Cauchy-Riemann equations are satisfied at x is equals to 0. Okay, that is at origin you can assume that is x0 and y0, and whether f is analytic or not. Okay, so for that what you have to check, Cauchy-Riemann's equation are ux has to be vy and uy is equals to minus vx. These are Cauchy-Riemann equation. So let's find out the differentiation. Okay, so how can we find out dux? Ux is del u by del x, correct? The points are 0 comma 0, right? So it will be limit, this is how you can solve it, limit h tends to, because points are origin, h tends to 0, u x, because you are differentiating with respect to x, x will be there, comma y will be 0, minus u, points are for function u, points are 0 0 here, just like if you see the analogy, fab divide by h, correct? Okay, now tell me, if in this function you put x as 0, what you will get? 0 only. And if you put 0x, 0y, so 0 divide by h, limit h tends to 0, correct? So 0 by h, don't substitute h as 0, otherwise it will form 0 by 0 form. Firstly, do it like this, 0 by h, and we know it will be 0. Similarly, if you have to find out uy, what it will be? Del u by del y, correct? So del u by del y will give you that too at 0 comma 0, right? 0 comma 0. Just bear with me. It will give you limit k tends to 0, u, now x will be 0 because you are differentiating with respect to y, minus u 0 comma 0 divided by k. Now again, if you substitute 0 in place of x, you will get 0, correct? Minus 0 by k, that is 0. Okay, so can I say that ux is equals to vy, sorry, ux is equals to vy because Vy is given to us as 0. So first equation is satisfied. Now for second, because it is 0, can I say, because 0 is neutral anyways. So if I substitute here 0 and here minus 0, these are equal. So can I say that Cauchy-Riemann equation is satisfied? Which question has asked for? Now the second part is to check analyticity. Okay, and for analyticity we have to check whether the function is differentiable or not. Correct? So how can we check that? Let me find out space for you. Okay, so in order to check the differentiability, the formula is u dash at a particular point is limit z tends to 0, the function, its value at a certain point, divided by final value minus initial value. This is how you can find out. So it is nothing but lambda z tends to 0. uz is what? The function is given to you in terms of z, because you know what is z? Fz is nothing but u plus iota v. So this is given to you as question, minus u0 is 0 divided by z. Z is what? U plus iota v. Correct? Now if you are considering xy in numerator, so you have to make it x and y form only. Okay, so I am putting here, instead of u plus iota y, x plus iota y. Instead of u plus iota v, I am putting x plus iota v. Is it fine? Now what it will give you? Can I consider y as mx? This is the line which can pass through origin. Yes or no? Pass through origin. So if I substitute y is equals to mx here by putting x tends to 0, what I'll get? X is here. Instead of y, I am putting the value of mx. Is it fine? Divided by x is here plus instead of y, in place of y I am putting mx. Okay? Now what you will get? Limit x tends to 0. See, if you multiply x into x, it will be x square. X square will come out from under root to become x. What is there in the root now? M. In denominator, can I take out x as common? 1 plus iota m. Now x gets cancelled out. There is no x, so the limit, if you just put x as 0, there is no x, so limit will be 1 plus iota m. Now if you have to check whether it is analytical or not, we have to check differentiability. Now this function is dependent, the value of this function is dependent on the value of m, because the fz depends on value of m, so it will vary. Yes or no? Its value varies, and if it varies, what we will say? It is not differentiable. If it is not differentiable, then it is not analytic either. I'm hoping that you are clear with this point, and if so, then don't forget to like, share and subscribe our channel. Till our next video, take care of yourself. Bye bye.